Welcome to our first day looking at hands-on equations. So hands-on equations is a system that we are going to use and explore to help us be able to solve different types of equations. First thing I want us to do though is just look at these two examples. So we have an example of an expression and an equation. What are some things that you notice that are different between the two? What does an equation have that an expression does not have? Hopefully the one thing that stood out to you is that that equation has an equal sign, whereas an expression does not. Meaning, an equation states that two expressions have the same value, right? So that equal sign is the main thing that's different between the two. All right, so I want you to pause the video and I want you to take just a couple minutes to write down everything you know about the picture on the left. All right, hopefully you notice that this is a balance. And so it's a type of scale, whereas if we put something on one side and not something on the other side, the scale is going to tip to show which side is heavier. Our goal with these is always to get the two pans to be equal, because then that means that our scale is balanced. And we're going to use that idea as we work through our equations, because we know that we want both sides of an equation to be equal in value, like a balance. Looking here, we have a balance. On one side, we have what we're going to call our triangle or our pawn. And on the other side, we have this block with a 6. So what do you think Maria could replace our triangle with so that the scales remained balanced? Hopefully, you said that we could replace it with a block that also had a value of 6, because as long as they're the same, the balance would be the same. Now, we could also do anything that has a value of 6, meaning I could have also put in 2 blocks that have a value of 3, because those together would also equal 6. All right, I want you to pause the video and thinking about what you see here in our balance. What do you think we could replace our pawn or our triangle with in the picture to help us out? All right, so some things that we notice is that there are 2 triangles on one side, and we have an 8 on one side, or on the other side, and that the 2 sides are balanced. So since they're balanced, we have to think of something that when it is put together would equal 8. In this case, it would be 4, because we know that 4 plus 4 is equal to 8, so that would check out. One thing I want you to remember then is that our triangle, when we use it, like when we did our puzzles, will always have the same value within an equation. The value might change from equation to equation, but within that single equation, the value remains the same. So we couldn't, for example, do 5 and 3 here, because the triangles have to have the same value. Now let's look at another example. So here we see we have a triangle and 2 on one side of our scale, and we have a 9 on the other. The way that we're going to do this in our work is we're going to represent it kind of looking like this, where we're going to have a line to represent our balance, and then usually we're going to draw a line in between that shows the break in the balance, or where our equal sign would be. So what could I put in place of my triangle to that would keep it balanced with the 9 on the other side? Hopefully you said 7. And one of the things that we're going to include in our process is we're going to do something called a check. So I'm going to do 7 plus 2, because that represents the left side of my equation, has to equal 9. And 9 is equal to 9, so it checks out. All right. So I want you to try these two on your own. So go ahead and pause the video and see what you would get for your answer for each. All right, on the first one, as we're looking at this, we know that 1 triangle and 8 have to be balanced with 3 triangles. So maybe what we figure out is that our triangle is going to equal 4. So I would make this 4 plus 8. It has to be the same as 4 plus 4 plus 4. Well, 4 plus 8 is 12, and 4 plus 4 plus 4 is also 12, so that checks. On our next one, we have a triangle and 8 have to equal these two blocks, which together equal 14. What can I replace my pawn or my triangle with that would go together with the 8 to give us a value of 14? In this case, it would be 6. And one way that we could look at that is we could also swap out these blocks. So for example, I could swap out the 10 and think about that being 8, and then make this into a 6, because then we would see those equal values on both sides. So that's something to kind of think of too, is like, how can I decompose or break apart my numbers? So I'm going to do my check. So 6 plus 8 has to equal 10 plus 4. 6 plus 8 is 14. 10 plus 4 is also 14, so that checks as well. Now, eventually we're going to get to a point where you're not going to be given equations with the triangle. We're going to get given the equation in an algebraic form, meaning that we have this x here. So what we're going to do right now is we're going to represent what we did before using our pawns. So here's my balance. Okay, so 3 x's means I have 3 of my triangles. For what we're doing, we're going to make sure that we shade in our triangles, because as you get further on in math, there's going to be a difference between what we call an open triangle and a closed triangle or a shaded triangle. So on the left side, we have 3 triangles, and then on the right side, we have a triangle and a block of 4. So that triangle is also known as x. So here, what do we think our x would be? I'm going to say that my x is 2. So if I do 2 plus 2 plus 2, that has to equal 2 plus 4. 6 is equal to 6. So that works as well. All right, so I want you to go ahead and pause the video, and I want you to see if you can model and then solve both of these. Starting with the modeling, 3x means I'm going to have 3 of my triangles and a block with 1, balanced with 1 triangle and a block with 7. So starting to think about what's the same on both sides, what's different, and things like that. So as we start to look through this, maybe we determine that our triangle would have a value of 3. So we say that x equals 3, and our check would be 3 plus 3 plus 3 plus 1 has to be the same as 3 plus 7. 3 plus 3 plus 3 is 9, plus 1 more is 10. 3 plus 7 is also 10, so that would check. Our next one, we're going to have 4 triangles balanced with 3 triangles, oops, and a 5. So as I kind of think through this, I see, for example, that both sides have 3 triangles, so those would be the same, meaning if we kind of look at this, it would make sense that our triangles have to equal 5 in order to make it balanced. And if we check that out, we have 5 plus 5 plus 5 plus 5. Or another way we can do this is we can actually go back to our original expression here and make this 4 times 5 is the same as 3 times 5 plus 5. So 4 times 5 would be 20, 3 times 5 would be 15, plus 5, 20 is equal to 20, and that checks.